So, hello everyone. I hope you all enjoyed lunch. Not too much so that you can stay awake for the next 50 minutes. It's not a really deep dive, so it's probably a good talk for after lunch. You don't have to pay too much attention. And I will wake you up at the end for the next session. So I'm going to talk about processing IoT sensor data with InfluxDB. So I mainly show you how you can process IoT sensor data, but basically you can store any data in InfluxDB, as we will see later in the presentation. So my name is Johan Janssen. If you have any questions later, feel free to email me or tweet me or whatever you want. So what are we going to do? Basically, I'm going to give a bit of an introduction about why I did this project, and then we're going to see how we can store data in InfluxDB and how we can visualize that data in a nice way. Is this a marketing pitch? No, I don't work for any of the companies which products I show you. I work for a consultancy company in the Netherlands, so they don't have anything to do with that. I don't have any stock options, so for me, feel free to replace anything you see with different technologies. I used InfluxDB because I was looking for a time series database. I wanted to play around with it. And the first things I saw about it looked quite good. There were some Java libraries available for it. Quite some documentation available. So I simply used that one. But there are multiple time series databases. So feel free to decide to pick another one. The same goes for Chronograph, which I use as a dashboard, but I also used Grafana, which is used a bit more often. You can use that as well, but Chronograph has a bit nicer integration with InfluxDB because it's from the same company. Next to that, I use Spring Boot for for most of the examples, but you can use most of the stuff without Spring as well, although I will show some Spring-specific stuff. If you have any questions, please feel free to ask me immediately. You don't have to wait until the end. So that's it. Why did I start with this? Basically, I like to try out new stuff. Probably not this. This is not the best probably to drink. But I like to try out new technology and play with new things, like the time series databases. Next to that, I have a garden where I have quite some vegetables and fruits. And I wanted to increase my harvest, basically. I wanted to have more to eat. And that's actually going quite well. I think for the last couple of months, most of the food we eat comes from our own garden, so it's working quite well. Next to that, I have a basement. Looks a bit like this, but more with empty bottles. And what I wanted to do was basically control those environments. So in my basement, I want to control the humidity, because if it's too humid, it's not good for the beer or any other stuff you have in your basement. So I could simply buy an off-the-shelf dehumidifier and then be done, but I'm an IT nerd. I like to do things myself, and I like to have a bit more control over it. The same goes for my garden. I could simply use off-the-shelf stuff, although this one probably is a bit expensive, or a bit more simpler like this one. To basically measure different things in my garden and try to influence them. But I mean, what would you measure in a garden or in a basement? Basically, for my for my garden, I want to know if it's sunny, if it's dry, or if it's wet, how good the quality of the soil is. And basically, based on those input, I can give more water to my plants, apply some fertilizer, and stuff like that. What makes it more complicated is that basically every part of the garden has different requirements. It's almost like a software system. So some parts need a lot of water, some parts need less water. Flowers, for instance, they can survive quite well without too much water. If you want to harvest lots of fruit and vegetables, they need more water. Different flowers have different requirements again. By now you're probably thinking, where did I end up? All the flowers and garden stuff, I didn't come for that. Don't worry, that's basically the introduction, so we will start with the technical part now. So what did I use? I used a Raspberry Pi with a few sensors, which can measure all kinds of things, which we will see in a minute. These two are basically Bluetooth sensors, so you can connect them with Bluetooth. They are from Xiaomi, quite famous Chinese company. Be aware if you buy the sensors, a lot of sensors you need a bridge to connect to the sensors, and that bridge needs to be connected to the internet. And for me, the Chinese government doesn't need to know what I do in my garden, so I didn't want to use that. But some of the sensors are accessible by Bluetooth as well. So these two can simply connect with Bluetooth, and I don't need an active internet connection for it. Next to that, I have a BME 280 sensor. It's a small thing over here. It's connected to the GPIO ports of the Raspberry Pi. And that's basically an alternative for the Bluetooth measurements that I have. So for Raspberry Pi, I often get the question, which version of the Raspberry Pi should I buy? And these are probably at the moment the most popular ones. This one is missing the Raspberry Pi 4, and that's with a reason, because from what I heard is that it's generating quite a lot of heat and isn't really stable at the moment. So I don't know if it's a good choice at the moment to pick that one, so I didn't include it yet. I'm mainly using 3B Plus Raspberry Pis at the moment and Raspberry Pi Zeros. So the Zeros, they have a lot less capacity. It's not a quad core, it's simply a single core, but it consumes a lot less power. So basically, what flavor would you pick? There are a couple of reasons for that. Money, the Zero is a lot less expensive than the Raspberry Pi 3, for instance. But also power consumption. If you look at these charts, you can see that for the 3B Plus versus the Zero, there's quite a big difference in power consumption. And if you want to maybe put a Raspberry Pi in the garden where you don't have a power outlet, but you power it from a battery or something like that, then it's really useful if it doesn't consume that much power. And for most of the stuff that I show you, reading sensors and everything, a single core processor is more than enough. However, when you start experimenting with it and you want to try some stuff and want to run some new applications on the Raspberry Pi, I can highly recommend you to buy a more expensive one, a quad core, because compiling stuff, building stuff is way faster on those machines. So for experimenting, I would advise you to buy a faster one, unless you want to drink a lot of coffee and wait a lot of time. So this is basically my setup. I have the Raspberry Pi, which I've shown, and the different sensors, and I use a Spring application running on my Raspberry Pi to basically retrieve all the sensor data. In detail, these are the different sensors that I use. Oh, one sensor I didn't mention, but the Raspberry Pi also has an internal sensor to measure the temperature of the Raspberry Pi itself. And for the rest, I use the Bluetooth sensors and the GPIO sensors, which I've shown before. Okay, so what can I measure with those different sensors? These are the different things I can measure. So temperature, humidity, moisture, but also things like battery level. For the Bluetooth sensors, they work on a battery, so it's quite useful to see how good the battery level is so that you can replace the battery before it's empty. And so again, where will we build the application? Will we build the application on the Raspberry Pi, or will we build it on a laptop? So we could use the Raspberry Pi or the laptop. I always build my stuff simply on my laptop. It builds the Java application a lot faster than on the Raspberry Pi. And I sync my output folder in IntelliJ with a directory on my Raspberry Pi, and then I can simply execute a Java command to start the jar file on my Raspberry Pi, but all the building happens on my laptop. Again, simply to save time and develop a bit faster. If we look at the setup for InfluxDB, what I simply do is I use Spring to retrieve the data from the different sensors. And then I use Spring to send the data to InfluxDB, the time series database. And I use Chronograph, a dashboard, which basically retrieves the data from InfluxDB and creates nice graphs for it. I run all that with Docker Compose. I run everything on the Raspberry Pi, so I even run InfluxDB and Chronograph on the Raspberry Pi. This is a quad core, so it's quite capable of it. If you have a Zero, then probably it's better to run InfluxDB and Grafana on another machine because it's a bit more resource limited. Docker Compose makes sure that everything is started up on boot, so even if my Raspberry Pi crashes and reboots, it will come back up immediately after reboot. So a little bit about InfluxDB and time series databases in general. So time series database is perfectly suited for data with a timestamp. That's why it's called a time series database. So a time and some event. And those events, that can be basically anything. It could be the temperature from a sensor, but it could also be an exception in your application. If your application is throwing an exception, you have a time that the exception occurred, and you could store it in a time series database. One thing I will show later as well is that for some methods, I measure how long they take to perform. So for instance, I have a method which retrieves the sensor data from the different sensors, and I want to know how long it takes to execute the method, so that I know how fast the sensor is responding. All those measurements, the duration basically, it's also an event which occurred at a certain timestamp, and I can also store that in the InfluxDB database. So basically any data which has a timestamp can be used. Of course, I could have taken a more traditional approach and maybe use like MySQL database or a SQL Server database or an Oracle database. They have support for time series data as well. But for me, it feels a bit like using a hammer for everything. While there are tools that are specific for the job. I tried to look it up, and for instance, to see if there were any speed comparisons, if a time series database would be faster than a more traditional database. And I couldn't really find a good answer. Basically, the people who build time series databases, they write reports and say that their stuff is faster, but I don't trust that. But I think it depends on the situation as often. It depends on what kind of data you want to store, how often you want to store data. So I don't know if it's faster or anything, but I just wanted to play with it and have a dedicated, quite simple database to interact with. So how do we interact with the database? So first I start InfluxDB in a Docker container, which is running on my Raspberry Pi. And then I can basically start another Docker container, which will execute the InfluxDB command and basically gives me a command line interface to the InfluxDB database. Then I can use some commands like show databases, which will give me a list of all the databases. And I can say use from a database name, and then I'm basically logged in to that specific database. I can show things like measurements. But let's just show it live. That's probably more interesting. Network error, of course. Interesting. So in a demo, always something has to go wrong. So we had that part. So hopefully now the rest all works flawlessly, which doesn't look like it. And let's see. Let's reboot for a second, see if that helps. And I'll just continue with the presentation, and we'll go back to the live demo after the Raspberry Pi has rebooted. So with show measurements, I can basically see what kind of things are measured. And in my case, I measure things like ambient pressure, ambient temperature, battery levels, etc. So these are basically the different kinds of things that I store in a database. I can also say show series, and show series basically makes a combination. So for instance, for the ambient humidity, I have two different sensors that measure the ambient humidity. So the series show all the different combinations I can make from my measurements. I can quite easily query the data, and this looks quite like normal SQL, which probably most of you have seen before. So you can use things like group by and all kinds of other things that you're used to from SQL. I have to say they're also working on a more like streaming-like query language. But when I was working with it, it was still experimental, and you had to do quite some stuff to make it work, so I didn't include it yet in the slides. But if you like more streaming query languages, then maybe you have to check out that option. I like this option because I can write SQL, and this was quite easy if you know how to write SQL. So if we do this query, we perform the query, we get a result like this. So the ambient temperature, in this case from the sensor hygro thermograph sensor data. And we get all the timestamps, the host, and the different values for the temperature. Who of you can tell me what time or date this is? No one? It's easy, right? Now, it's quite annoying. I don't know why they show it by default. I think it's a performance improvement or something like that. But for like normal mortal humans, it's probably easier to execute this command, precision RFC 3339. And then if you execute the query again, you get sort of a normal timestamp that's a lot easier to read. So that's something that I try to do immediately. Let's see quickly if my Raspberry Pi already booted again. Okay, interesting. Because the idea was that I would use it for the rest of my demo as well, which is a bit difficult if it doesn't work. Of course, it worked when I set it up before you all went to lunch. It all worked perfectly, and then you return, and of course, it doesn't work. Okay, we'll simply continue with the slides. So we've seen how to retrieve data from the database with select statements. We could retrieve all the data. We can also store data by using SQL-like queries, by simply saying insert and then the stuff that we want to insert, and then it's inserted into the database. But of course, I mean, this is more a Java conference, so you're probably waiting for some Java. I use Spring Boot with a few different options. So basically, there is an option to send the data to InfluxDB by using the InfluxDB REST endpoint. The other option is to use the InfluxDB Java client, which is a client which connects to InfluxDB to store the data. You can use that one directly, or you can use the Spring Data InfluxDB, which uses this one underwater. So this is a bit easier to set up, but underwater it uses this one as well. So that's a bit the different options that you have. If you're not a Java programmer, but you use another language, these basically clients exist for a lot of different languages. So basically look for a client for your specific language, and it's probably there. And if it's not there, you could simply use the REST endpoint, because I mean every language supports REST basically nowadays. To set it up, it's relatively easy. First, we create an InfluxDB instance. We specify where InfluxDB is living at the moment. We create a database to store the data, and then we say that we want to use that database. And then basically, we've got it set up. If we would do it in Spring, we could wrap this in, for instance, an add bean annotation, or we could specify the properties in a property file to make it a bit nicer. But it's relatively easy to set up. And after you've set up everything, you can program using the library. And you do that by using points. So every measurement that you have is basically a point. We define the name of the measurement, in my case ambient temperature. We define the time, so the current time, and then we store the different information that we want to store, and we build it. You saw that maybe in the slide before, we use tags and fields. And the difference basically is that the tag is indexed like a column in SQL, and a field is not indexed. So if you want to query on something, probably you want to use a tag for it. And if you don't want to query on it, then probably a field is a good solution. After we created the point, we can use one of the different commands to write the point to the database. So there is a simple one to simply write the point, but there is also an option to specify all kinds of information, such as the retention policy. And the retention policy means that how long that you want to keep the data in the database. And so this is for basically sending one point at a time. If you have a lot of points and you send a lot of points to the database in a small amount of time, then probably it's good to use the batch mode to basically bundle a set of points and send them to the database at once to increase the performance. And you can do that with this option. So basically this will try to retrieve 10 actions and flush after, I believe this is 1 second. For my solution, I didn't use the batch mode because without it, it performed good enough as well. So this was by using the normal Java client for accessing InfluxDB. So you can use this without Spring as well. What we will now see is the Spring solution. So this is integrated within Spring, and you need Spring to do this. To make it work, we use a few properties in the property file of Spring to specify the different configurations. After that, we can auto-wire an InfluxDB template, and the InfluxDB template can then be used to store everything in a database. So we can use create database and InfluxDB template.write, and you see that write supports both writing a point and a list of points. So underwater, it does some batching and stuff to make it easier. So it's quite comparable to the previous solution, just a little bit nicer, a little more extra abstraction layer on top of it. So if you're using Spring, I can highly recommend you to use this one. I've used both in my example, but this one is a bit shorter and a bit less configuration. If you have the possibility, I would always use these ones. You can also use REST, as we will see, but REST is a bit more difficult to set up. Or difficult not, but it's more ugly basically. So what we do here is we create a big string with all of the information, and then we post the string to the specific location where the InfluxDB is listening with the post for location within Spring. So this way we can store the data to the REST endpoint, but it's all string concatenation and stuff. It doesn't really look nice from an object-oriented perspective or from writing nice software perspective. So this is basically like a last resort, if you ask me. So we've seen how we could store the data with different Java clients or with REST. We can also retrieve the data in the same way. So we can write a query, just as we've done before on the Raspberry Pi with the CLI. We simply create a select statement, we group by. We have to manually say which database we want to use, and then we can say InfluxDB template.query, and we will get a query result, and basically we're done. At least that's what I thought until I got the result, and the result looks like this. So it's basically arrays in arrays in arrays. It's really annoying because if you write tests for this, a test will look like this. You have to get everything out of it, and as soon as some columns change, you're basically screwed. You have to write everything again. So I don't like to use those indexes. It's really brittle. Luckily, there is a fix for that, and that's basically by wrapping the results. Wrapping the results looks a bit like if you use JPA and you have entities. Basically, if you retrieve the data from the database, you store it in the entity, which is basically a Java class, and then you can use the getters on the class to retrieve the data. Wrapping the results in InfluxDB almost does the same thing. We specify a class where all the data will end up in. We say that which measurement it is, in my case ambient temperature. I specify the different columns, and I specify if it's a tag or not. So this looks a bit like the entity in JPA. Next we will again execute the query, but then we will use the result mapper. And in the result mapper we will say, okay, the query result has to be mapped on the ambient temperature class, which you saw here in the previous slide. So now it's nicely put in a class instead of in arrays. And then the test will look like this. So we still see a little bit of getters because it's a list inside the class. But for the rest, we can simply say things like get value, which is a lot nicer to write and read than the previous result. For the dashboards, I'll quickly check in between if maybe it is back, but apparently it's really annoying today. And at the moment, I don't know why exactly it's not working, because it looks like everything booted. Luckily, we have some slides, but it's of course nicer to see it live. So if we look at the slides, in Chronograph I can basically create new dashboards, and in a dashboard I can easily click basically on the values that I want to show you. I don't have to write any queries, although I can write a query if I want, but you can use the GUI basically to say, okay, this is the measurement that I have, and from that measurement I want to have the mean values or any other information that you want to retrieve from it, and then it automatically generates the query, and you can adjust the query if you want to. And then we can basically create dashboards for anything. Basically the simplest one is probably the temperature. So this shows the temperature from the 3 different sensors. This one shows the humidity and the temperature of the BME 280 sensor. So this is for all sensors together. This is the measurements from one sensor, and this is also the measurement from one sensor, but then all the different values that are being measured. This one shows the method duration, so basically how long does it take for a method to complete, and the method basically does the call to the sensor and sees how quickly the sensor responds. One thing to keep in mind, if you use the Chronograph dashboard, by default it doesn't auto-refresh. So you have an option at the top to say, okay, I want to auto-refresh every 5 seconds so that I see the latest state of the dashboard. If you don't do that, then basically you're looking at all the information. First time I worked with it, I was a bit surprised that nothing showed up. So don't forget to basically make sure that it's automatically reloading. So some of the challenges, except for that Raspberry Pi. So I try to use different frameworks, Java frameworks, to get the sensor data out of it. There are some quite nice frameworks like Py4j who offer support to retrieve data from the GPIO ports and things like that. The downside was that some of them are quite old. They aren't updated. They don't support the latest Java version. I wanted to run everything on Java 11 because, hey, Java 11 is out for a couple of years. Why not? And I mean, customers don't use it, so I just use it myself. But that didn't really work because Py4j didn't have support for Java 11. Some other things were lacking. So it was a bit of a pity. I mean, the IoT world, it's still a bit of a Python C world, and not. Yeah, there are some Java projects around it, but they're not used that much, and they don't offer so much support as the C projects or the Python projects. So I wanted to do everything in Java, but in the end I was like, okay, maybe it's easier to not do everything in Java and get my hands dirty a little bit. So I tried to use some tools that were available. I used some Bluetooth stuff from Raspberry Pi that was available, and some stuff that was a bit more low level than the Java stuff that I intentionally wanted to use. To do that, within Java, you can quite easily execute a command on the command line by using the process class. Of course, there are better options, such as JNI and stuff like that, but it's more difficult to set up, and this was quite easy for me to set up. So if you have a command, I could perform, for instance, a Java command here, or a directory listing in a Linux command, or anything you would do normally in a terminal, basically. Then you can retrieve the output by saying, okay, I want to have a scanner, and based on the process, I want to have the input stream, so then I get the result back. I want to send a signal to my sensor, retrieve the data, I get the temperature back, and I want to retrieve the temperature in my Java application. Next to that, there was also an error stream, so if something went wrong, I would get an error back. So that was quite nice, was working quite nice, and I thought, yeah, now I'm done. And it worked quite nice for a while, but after like 45 minutes, I wouldn't get any values anymore within my application. The sensors weren't read properly anymore. It simply stopped somehow. And I first thought, yes, maybe something out of memory, my disk is maybe full or something like that. So I tried all kinds of things, profiling the application, lots of debugging, and nothing basically worked. And I couldn't really understand why that was. And the most annoying part was that I could perfectly reproduce it after like 45 minutes. So every time I changed something, I had to wait for 45 minutes, and then I could see if it worked. And the problem was it didn't work most of the time. And after a while, I was like really upset, like why doesn't it work? And then I found this little command, process.destroy. And basically what that does is it kills the process that's being executed. So if I, for instance, executed a Java application, this command will stop the Java application. So here, what I do is I try to retrieve the sensor data from with Bluetooth, but if that doesn't work within 20 seconds, I will kill it. And then basically after that, it was fixed. It ran more than 45 minutes. Actually, it could run for a day. I didn't have any issues anymore. So it looked like that there was something wrong in either the Bluetooth application I was using on Linux, or maybe it is that these devices weren't really meant to be used with Bluetooth, and maybe they take a really long time to respond sometimes or something like that. But this, for me, fixed the issue without in detail knowing what went wrong, but it was solved, which was a bit like, why? Another thing that I found a bit surprising was this, ambient temperature. So this is the temperature from the 3 different sensors. Anyone notice something strange in this graph? Or does it look normal to you? It doesn't start at 0. Yeah, that's a good remark, but it's automatically scaled by the dashboard. So the dashboard will remove everything which isn't used. So my temperature was always above 20.9 degrees, and the rest is skipped. Yeah, good remark, but it wasn't the thing I was looking for. Anyone else who sees something strange here? The fact that I'm measuring the temperature and I get 3 different values isn't surprising to you? Okay. And so there are different temperatures from the different sensors, while all the sensors were laying on the same table, basically. And then the question is basically which sensor is lying. In the end, it doesn't really matter as long as you use the same sensor everywhere. So I wanted to have multiple sensors in my house and in my garden. And if you use the same sensor everywhere, it doesn't really matter. But if you mix them, it's a bit annoying because you never really know what the temperature was. It's difficult to compare them. And what I heard is that the small sensor on the GPIO is apparently quite good. It has a quite good accuracy. And maybe the Bluetooth sensors, the accuracy is maybe not that good. But I don't have professional equipment, so I didn't verify it. But it's something to be aware of. If you use different sensors to measure the same kind of thing, it can be hard to make good comparisons with it. Another thing, like I mentioned, I store the exceptions, and maybe it's interesting. I can't show the live demo, but I can show the code which went with it. So what I do for every sensor data that I retrieve is that I measure the duration, and then I have a duration point, and what I simply do is I store the duration of the method, which is measured here, in milliseconds, and that's being stored in the database. So this is something you could do in any application, also in big server enterprise applications, not only on Raspberry Pis. And if an exception occurred, I will create an exception point, and I will basically store the message and some extra information in the InfluxDB database as well. And then afterwards, I can basically query or visualize the exceptions that occurred in my application. And what I found out after running it for a while was that the hygrothermograph and the FLORA sensors, they were causing the most exceptions. And I did quite some runs, and most of the time the result was comparable to this. And probably it's basically through Bluetooth, and partly maybe also because I destroyed the connection after a while. But the Bluetooth sensor is a bit more brittle. We can see the same from the response times. If we look at the response times, these are the response times for the Bluetooth sensors. So this is like 8.5 seconds almost, like 8 seconds, 5.5 seconds. And the other sensors are down here. It's basically a flat line because the rest is that high. If we look that up a bit more in detail, we can create a select statement for the mean duration, for the method duration, and group it by sensor, and then we get this as a result. So we see that the Bluetooth sensors are relatively slow, the BME 280 sensor is way quicker, and the Raspberry Pi integrated sensor is, yeah, of course, the quickest. It's integrated in the Raspberry Pi. So some are really slow, some are relatively fast. So yeah, which one to pick? For me, it's not like something is scary or doesn't work. I mean, I'm fine if I have a measurement every 10 seconds, but if you have an application where you want to make sure that every second something is being logged, then the Bluetooth sensors are way too slow. So it depends a bit on your application if you want to use them, but in general, I think it's fast enough. The same goes for the exceptions. I don't really mind that I have an exception now and then, because I measure every 30 seconds, and even if half of my requests goes wrong, I still have a measurement every minute, which is more than enough for me. And like the 27 errors that you saw before, that's while running like a couple of hours. So I have more than enough measurements. So for me, it's not really an issue. But if you want to have all the measurements, then probably it's better to get a bit more reliable something than a Bluetooth sensor. So for me, it worked quite well. So as a conclusion, I quite liked InfluxDB. It's quite easy to work with. If you know a bit of SQL, you can easily use the command line interface for it. Works almost the same. I also really like it that it has a really nice Java client, so I can use Spring to basically program everything, and then I can quite easily say store it in the InfluxDB database, and then I can create the dashboards really easy. I couldn't show it now, but if we go through the steps, I basically say, okay, my InfluxDB database is running here. I tell Chronograph that, and then Chronograph will automatically connect. It will show me a list of all the measurements that I make, and I can simply click on the measurement, and I can say how I want to visualize it. If I want to visualize it with bars, with graphs, or whatever, I can give it different tags, different names, different colors, all without programming. So basically, the only programming I do is to store and retrieve the sensor data. So relatively easy, and I quite like to work with it. I've got quite some experience with traditional relational databases, which also work quite nice, but for time series, this is quite a nice application. If you want to look into it or want to run it yourself, there's the Sensors to InfluxDB project on GitHub. So this includes basically everything, not only the Spring application that I've shown before, but also all the scripts to configure everything. To download the libraries, the configuration that you need for your Raspberry Pi. So if you have a Raspberry Pi with Raspbian on it, you can run these scripts and it will automatically configure everything for you. So that saves you quite some time. The Docker containers, everything, it's all in the scripts already, so you can easily start using it. One disclaimer, I made the code as easy to understand as possible, so I duplicated some parts so that's easier to show. So don't blame me that the code can be written better, I know that already. And so to look a little bit how the code is structured, basically I use a lot of Spring stuff. For instance, to schedule how often I want to retrieve the sensor data. So you can see at the bottom that I specify a schedule.rate, which in my case is 30 seconds at the moment. And every 30 seconds, I will retrieve all the sensor data by saying retrieve and sensor data.start. And then it will basically, for every sensor, it will connect with either Bluetooth or however the sensor is connected. And it will retrieve all the data. And then it will send all the data to the database. So here we see how different points are being created. So I can create like the temperature point for the temperature of the Flora sensor in this case, the battery level, the lux, conductivity, moisture points. I can put them in an array and then use the Spring InfluxDB template to write all those points at once to the database. So it's all fairly simple Java code if you're used to writing Java. Nothing really fancy in it. I think the ugliest part is executing command line stuff. So for instance, the stuff that I use for Bluetooth. So I do a lot of wait for and destroy stuff, which I've shown before in the slides. So this is a bit the ugly part that interacts with third-party stuff. And then reads the third-party results into my Java application, and then the Java application will handle all the rest. So that's basically the application, and it's basically configured for all the different measurements. So it looks like a lot of code, but the reason is that for every sensor, I store the sensor data with all three options. So with the Java client, with the Spring client, and with the REST client. So basically all code is 3 times duplicated. So it looks a lot more than you normally would need. But for the demo, it's a lot easier to use. So, any questions? While I quickly check the last time if it's running or not. That probably. So sorry for the demo, but most of the stuff you saw in the slides already. Except, of course, it would have been nicer to see it live and see the live temperature measurements. For whatever reason, it failed this time. But I can highly recommend it to try it yourself. So you could easily run InfluxDB on your machine and simply send some Java, use some Java commands to send whatever data. I mean, you can just send random data or generate your own exceptions and store them. And then you can easily use the dashboard to visualize it. What's the battery life if you Bluetooth sensors with Good question. So the question is, what's the battery life of the Bluetooth sensors if you record every 30 seconds? It goes down quicker, but still it's quite some time. And I measure the battery level as well, so I can replace them if they're almost zero. So yeah, you would need some batteries if you pull every 30 seconds. For my solution, probably it would be fine to pull like once an hour. But for the demo, it's nicer to pull more often because then you can see the results coming in. Normally, I put my hand on the sensor and you can see the temperature going up. So it's mainly for demo purposes that I do it every 30 seconds. If you would do it like once an hour, it would be okay as well. And it would probably save you a lot of battery power. Yeah, good question. You were first, I believe. Yeah, so the question is, how long do you keep the data and why? I got the question more often, and for now I'm storing basically all the data, but that costs quite some disk space. What probably would be the nicest solution is to store all the data for like 2 weeks, so you can see in depth what is happening, or maybe for a month or half a year, and then store like every hour something which you will keep forever. Because, yeah, that saves you a lot of disk space. But it depends a bit on how much data you want to store and how often. But if you do this in like an enterprise environment, probably you don't want to keep everything forever, because then, yeah, your disk space will grow continuously. But it's a bit the same with a database where you could see that some data maybe is not really relevant after a year anymore, or hardly being used after a year, and it's maybe better to store it in a separate database or something like that. It depends. That's a good question. The question is, did I contemplate other solutions such as the ESP with some number which I always forget, a small computer, or I often get the question, can I use my, I know I forgot the name, of course, my Arduino for it, or other solutions with maybe MQTT, which you mentioned, or other stuff. I thought about it, and I think those are nice solutions, but I like to program in Java. And not in some really low-level language, although I've done that as well with some other projects. But I prefer to use Java, and then it's better to use a Raspberry Pi because those smaller devices cannot run Java most of the time. So that's basically the main reason. But functional-wise, you could use the solution you mentioned as well. Yeah, that wouldn't be an issue. It's more that I prefer to do Java. Yeah, so the question is, do you do watering of the plants if the moisture is going down? This was basically the first part. I wanted to get an insight about how my garden was doing, and indeed the next part is basically automating it and doing something based on the results. I haven't done that yet, but it's the plan to do that, to basically automate for the different parts in the garden how the watering goes. Because then I don't have to pay attention. I can just sit behind my computer all day. That's the ideal solution. I have a garden because I like to come outside, but for vacations and things like that, it would be good. Although I've heard some cases where something broke and basically the water was flowing out like for a week, and that's not good for your bill, and it's not good for your garden either. So you have to be a bit careful with that. Any other questions? Then thank you all for joining and have a nice day.